Hello and welcome to this Big Data 101 video. This video is intended for just for a fundamental concepts surrounding big data and Hadoop and how it evolved and what is the current implementation and what most if anybody is trying to learn or get into big data development and what could be approached. So this is a very introductory video. Subsequent video I'll be covering more detailed hands-on examples using Hortonworks and cloud data platforms. So first begin with let's start with what is big data. Actually, the big data, the concept, it has been there for a while, but it has got a recently heavy push from across the industry once the after Google released their Google file system, which actually led to development and evolution of Hadoop platform. So big data is any kind of data set which is extremely large and uh, it cannot be executed or processed using traditional data data softwares. Like take an example, any data which has large number of columns, it cannot be efficiently managed and processed using traditional data warehousing softwares or any database engines. So so big data has always been there. It has been managed by, like, take an example using softwares like mainframe, but the managing of these kind of hardware has been extremely expensive because the product been extremely expensive, and the knowledge and technology, it has been very proprietary. Like what is inside IBM mainframe, nobody knows outside IBM, and even though, and it's very hard to find that skill set of people. And the big data, and now in modern terms, the big data is usually used for analytics term. Like if you are doing some kind of analytic logic, take an example, you want to find, say you are a bank guy. Okay, you want to sell your credit card solution, and you want to come up with some kind of deal. So you will like to run an analytics on a large set of social media data to see what kind of people are, say, want to looking for buying a TV or something. So you probably tie up with a television or a retail company and show up a ad to the your potential customer. Okay, we have a offer if you buy a TV using my credit card. So like sometimes you may see these kind of ad, you think, oh, how he read my mind. Basically they track through your social media, internet activities, and your bank history, and based on that they can make some kind of recommendation. This is a very crude and example of how the big data analytics working right now. So so big data, when it comes, so I said this will be more we're discussing towards Hadoop is nothing but it is a map reduce implementation of big data using HDFS. So what is HDFS? HDFS is a highly available fault tolerant file system. It was invented by Google as a Google file system, and then when Google open sourced it, it evolved as a Hadoop distributed file system. The key feature of the file system, it keeps it separate from stand it out in the crowd, is that this file system assumes fundamentally that any hardware running on it, it can fail anytime, and the hardware is all commodity grade hardware. To run a Hadoop, you don't need to buy a like $20,000 IBM server with a RAID. You can pretty much buy a simple PC-based hardware, just normal SATA drive, and start running on it. So the design goal of Hadoop is you should be able to run your large computation operation using small cheap computers and create a distributed cluster and run your job on that. So so uh, so any, like any execution engine, even if you take an example of your CPU or your computer, it has two fundamental things. One is the processing unit, which is CPU, and second being your storage, which could be a memory, it could be RAM. So same way, if you are thinking of a distributed computing platform, so you need a storage and execution engine. So storage is provided by this Hadoop replicator file system. What it does, it you install this HDFS across multiple small cheap hardware. So I can create a Hadoop cluster. If you're talking about bare metal, I can have a 2-3 PC and run the cluster on it. And then you have execution engine. It could be a MapReduce or Spark. MapReduce being more popular and has been implemented using on Apache Hadoop. And later on, what they, I think in Hadoop 2.0, what they did, they forked the project. And earlier MapReduce used to do manage execution of the job as well as management of resources. They fork it to a different project called Yarn, yet another resource manager. So resource management is done by someone else and execution is by someone else. So if you want to correlate with the PC kind of world, so you think operating system being a resource manager, it knows, okay, if you have a 4-core CPU, it knows which CPU is the least busy, it will schedule a job over there. Similarly, Yarn sees which data node is least busy, it will try to execute your MapReduce job on that. And MapReduce, I'm using this term a lot, but just for now, just think of it as a MapReduce is a programming paradigm. It is a way you run, you program, you code your application to take an advantage of the distributing computing. So just a quick view of MapReducing, simple example like number count example. So you have a job, say you have a job of a say you have a 10 job. So what you do, you first do the map. It means you take that, say you have to calculate 10 numbers, so you distribute these 10 numbers across 10 nodes, and at the end of the execution and the reduce step, you reduce it and present it back to the whoever the executor. So it's a very basic example. You take the job, map it across the cluster, and at the end you reduce and merge all result and present it. This is one of the paradigm of programming in the Hadoop cluster. So this is a typical Hadoop ecosystem looks like. So in a Hadoop ecosystem, as I said, there will be a storage, which is your HDFS. Then you have a Yarn, which is your resource manager, and then you have a bunch of framework and programming paradigm you can use. And once we evolve through this whole discussion in subsequent video, we'll come up with Yarn actually is also replaceable, and same way you have a like MapReduce a program paradigm. You can use a Spark. Spark is actually implementation of MapReduce, but in memory, not in disk. So it gives you high performance. So then you have, and there are a lot of platform coming around like Kafka for streaming, and then you have a machine learning whole tool with Mahout and Spark mlib, and these are like pretty next level of thing, like where you have a Hadoop cluster and now you want to write application on top of it. And the most key thing as a when you start using it, you will see a lot of these kind of thing like Zookeeper and Ambari. Zookeeper and Ambari is nothing but it is a it is orchestration and management engine. So Ambari is a software piece of software which allows you to easily install, set up, and manage a Hadoop cluster. Because today, if you want to install a Hadoop on your own, pretty much you have to install a bunch of 20, 30 libraries, so many jar files. You have to numerous number of configuration file you have to edit in order to make a distributed cluster up and running. But Ambari makes it easy, and it gives you a very nice GUI format, and you can just do Windows style next, and it works. So, and now just touching base on the leading distribution. So we have Hortonworks, Cloudera, and Mappa are being the leading distribution. So distribution, what I mean is, if you're coming from Linux background, Linux, you have a Linux, and then you have multiple distribution like Red Hat is a distribution, Ubuntu is a distribution, you have Arch Linux. There are various distribution. They are nothing special. What they do, they take the Linux code and they package it according to their customer need or their market, and it sell it or resell it, whatever they want to do. Similar way, Hortonworks, Cloudera, they all base is the same, which is the Apache Hadoop source code, and they take it and they add some whistles and bangles to make it more appealing and easy to use for their customers. And this is the typical Ambari GUI looks like once your Hadoop is up and running. So typically you have a HD, it shows everything, like it has a nice dashboard also. It says how much disk you have, all any alarms or any issues you have. So the core of any Hadoop implementation, you always see, doesn't matter which distribution it is, you will have a HDFS, Yarn, MapReduce, and you will have Zookeeper. Zookeeper is a consistency management application. It keeps track of which node is active, which node failed down, which node is up. So it keeps track of each and every services across the cluster, so that any other service, say it's kind of service discovery. So assume if the Yarn wants to deploy a say Hive job, and it needs to know where the Hive server is running right now active. So it won't actually go to config file to find where it is. It will actually go to Zookeeper and try to find where the Hive URL is there and to fire the job over there. So it is a very nice kind of a bookkeeping guide. So that's why it says Zookeeper. So it maintains the quorum in the zoo. and this quorum word is actually used inside the application as well. So Zookeeper is to maintain the quorum because so many players are there, and you need to know who is doing what. So Zookeeper is the guy for you. So this is the I'll end here, and next subsequent video I'll talk about Spark, and we'll also do some hands-on example using Hortonworks Ambari tool. Thanks for watching.